you will have to fill in a unit circle by yourself on the test. So first we're going to practice the unit circle again because we're going to add tangents to it. So we're practicing patterns. If you know these patterns, then you should be able to fill in the unit circle. The first thing we're going to go through is fill in the degrees. So if you remember, horizontally, 0 degrees starts right here. That's a 0 degree angle. On all the different things we label, I think it's easiest to start with the 90 degrees. So all the right angles. So from 0 to here, we would now be at 90 degrees. Okay, 0, 90, and then the flat angle would be 180. And then 180 plus another 90 is, you're correct, 270. And then if you make it all the way back to 0 degrees, a full rotation is not 0 degrees, it's 360 degrees. Excellent. Okay, now in between them are the force. Okay, halfway between 0 and 90 degrees is what measurement?
45.
45. We'll use 60 a little bit. So that's the middle line, guys. The middle line is the 45 degrees. So we're going to find all the 45s. If we have 90, Gentry, what's 90 plus another 45? 135, yep. So let's write that right here. 135 degrees. Then in the third quadrant, we're going to add 45 again. Nui nui, what's 180 plus 45? 225. Okay, and then the last one, we have 270 plus 45. Admin, what's 270 plus 45? Thank you. 315. So we've done all the 90s, we've done all the 45s, now it's time for the 30s. Yep, we know first it's 30, and then it's 60. So here's the pattern. From here to here, there's always a 30 gap. From here to here, there's always a 30 gap. You don't have to draw those red lines. Actually, don't do them.
Why not? They're going to ruin your graph.
So we add 30, but then these little pieces are all 15 difference. Okay, so keep that pattern in mind. You go 30, 15, 15, 30. Or you could just, since we've already done the 45, you could just keep adding 30 every time for the remaining degrees. What's 90 plus 30?
20.
120. 120 degrees. 15 is 135, so another 15 would be 150. And it's true, if you add 30 to 50, we get 180. So that's good. Everything's matching up. 180 plus 30 would be 210. Plus another 30 would be 240. Plus 30 makes us at 270, which we have already marked.
And then it's 300 and 330.
Okay. So, yeah, 300 degrees and then 330. Okay, everybody raise a hand. Are there any questions on how you figure out all the degrees of the angles we focus on? Okay, so that's all the degrees. Now we're going to go through and put in radians. I'm going to erase these. It's right here. Radians. First we started out with 0 pi. Just like degrees, it's my opinion that it's easier to do your 90 degrees first. 0 pi, we know all the way around is 2 pi.
So halfway around is 1 pi.
Yes, halfway around is 1 pi, which means half of 1 pi. Austin, what would that be called for the 90-degree angle? If 0 to pi is 180, what was the 90-degree angle? 1/2 pi, or we can call it pi halves. That would be the same, but you're correct, 1/2.
So what happens if we Would it matter?
It does matter, actually. Yeah, it kind of only goes this way.
What's because, like, instead of 90 on
You just put on the side of the line, as long as it's the same line, then it doesn't matter.
Okay.
But it has to go with that line. Yeah. Okay, so we have, guys, you follow the fractions manual? So I have 1 divided by 2. 2 divided by 2 is 1, correct? So I have 1 divided by 2. 2 divided by 2, so the next one would be
3 divided
3 divided by 2, so 3 pi halves. And then 4 divided by 2 is 2. 4 divided by 2 gives us 2, which will be 2 pi. All right. Now the 45 degrees. So 90 is pi halves. What's half of a half?
pi fourths.
Ah, good job. Pi fourths. Half of a half is pi fourths. Because the 1 pi goes all the way out here to 180, and there will be 4 slices for 1 pi, which would be, 1 slice would be pi fourths. Okay, so pi fourths, that is 1 divided by 4. 2 divided by 4 is 1/2. 2 divided by 4 is 1/2. So the next one is 3 divided by 4. Which, guys, if you've already done your 90-degree angles, the 45s you fill in are just the odd ones. So this is 1 divided by 4. This is 3 divided by 4. In the third quadrant, what's the next odd number after 3?
5.
Okay, so 1 divided by 4, 3 divided by 4, so this would be 5 pi divided by 4. Okay, Joseph, after 5, what's the next odd number? Yeah, so 315 would be 7 pi divided by 4. So we've done all the 45-degree angles. Next is the 30 degrees. Okay, 30 degrees. How many, if this is 1 pi, how many slices are there for every 30 degrees? I have 1, 2, 3, 4, 5. How many slices in 1 pi? There's 6 slices. So every 30 degrees is 1 divided by 6. So we have pi over 6. Remember how the 30 doesn't have a denominator of 3. It doesn't match. Pi divided by 6. Now, it's true that 2 30 degrees equals 60 degrees. So if 30 degrees is 1 divided by 6, 60 degrees would be 2 divided by 6, but that simplifies. 1/3, so pi thirds. So we have 1 divided by 6, 2 divided by 6 simplifies to 1/3. What comes after 2? 3 divided by 6, and 3 divided by 6 is 1/2, which is our pi half, so it's already there. What comes after 3? 4 divided by 6. It's the even ones you have to be careful of to simplify. 4 divided by 6.
Pi fourths? No.
No. 4 divided by 6, they're both evens. Chibs, what divides into 4 and 6? 2. So we divide by 2, what would we get, Chibs? 2/3, so 2 pi thirds. So 120 is 2 pi thirds. So we had 1 divided by 6, 2 divided by 6, which simplified to 1/3, 3 divided by 6, which simplified to 1/2, 4 divided by 6, which simplified to 2/3. What comes after 4?
5, 6,
What comes after 4?
5.
5. So the next one is 5 pi 6. 1 divided by 6, 2 divided by 6, 3 divided by 6, 4 divided by 6, 5 divided by 6, and then at 180 we're at 6 divided by 6. And 6 divided by 6 is 1, correct? So we have 1 pi. Okay, and what comes after 6 divided by 6? M. 7. 7 pi 6. The odd ones, you don't have to worry about simplifying as much. Okay, what comes after 7, guys? 8 pi 6. This one simplifies, though. Noah, what would 8 pi 6 simplify to? Yeah, 4/3. Excellent. So 4 pi thirds. So 240 is going to simplify to 4 pi thirds. Okay, that was 8 divided by 6. 9 divided by 6, is that going to give us 3/2? 9 divided by 6, both divisible by 3. Okay, after 9 comes 10. Okay, Sela, what would 10 pi 6 simplify to? Excellent, 5/3. So 300 would be 5 pi thirds. After 10 comes 11 pi 6. And then 12 divided by 6 is 2, which is where we get 2 pi. Okay. Next, we learned coordinates for all of the, if this was on a graph, because we have an x-axis and a y-axis, we have coordinates. Since this is a unit circle, from the origin out to any point on the circle has a radius of 1. Okay. Heather, what would the coordinates of this point be for if the radius extends out 1 unit long? So remember, you do horizontal movement first and then vertical movement. So if I start at the origin, I move how many to the right? No, I move. If I move 0, I would still be here, but I've moved. What? 1. Yep. And then the vertical movement is 0. Yeah. So you have the right numbers. You just set them in reverse order. Okay. Then we have a point up here. Again, I'm starting with the 90 degrees because they're the easier ones. Benito, what are the coordinates of the 90-degree point on the circle? Yep. So left and right is 0, and then we go up 1. So 0, 1. 480 degrees. Adam, what are the coordinates for the 180 degrees?
1, 1.
Nope. So we start at the origin. We move to the left. How many? Negative. There you go. Negative 1, 0. Okay, Styles, what about this one down here at 270? So left and right, you don't move left and right at all. Backwards. You don't move left and right at all. You move down negative 1. So you have to say your x movement first. There you go. 0, negative 1. Okay. Now, for the remaining points, there's a pattern. We talked about this pattern before. You can work them out by hand like we did for the first day, but that takes you a lot of time. Or you can remember the pattern. All of these are fractions. But raise a hand, do you remember what the denominator is in all these fractions? M? 2, exactly. So on all the x's and y's, put it over 2, and then we'll fill in the numerators following the pattern. Following a pattern, we'll fill them in. Right now, we are above the x-axis, correct? We're on the top of the graph. So your starting point will be on the top. Okay, we're on the top of the graph, so the starting point is on the top, Adam. So, remember the pattern? What comes after 1? Ooh, root 2, yes. Root 2, root 3, and then you circle around, starting on the bottom now. 1, root 2, root 3. If I'm on the top of the graph, I start on the top left. Yes. If I'm on the top of the graph, I start on the top left. So for the next, and this looks like a negative sign, that was an accident. Okay, for the next quadrant, set it up. Again, everything's divided by 2. All of those are divided by 2. Joseph, you have that? Since I'm on the top of the graph, I'm going to start on the top left. There's my 1. I'm putting your starting position in black. So, on the first quadrant, we start in the top left. We'll get to the signs in a sec, but you are correct, yes. Okay, top left. Here, we're still on the top of the graph, so we, again, start on the top left. So what comes after 1?
2.
Root 2. It can't just be 2. It has to be root 2. Root 3, and then we circle back up. 1, root 2, root 3. Now, Christian, tell us what you just mentioned. Now, which part needs to be negative? Which axis is negative? The x-axis or the y-axis? Yeah, the x. So all of these need, all the x coordinates need a negative sign. Arbor, were you here when we passed out paper? No? Okay, can we get this piece of paper? And then probably borrow your neighbor's compass and draw a circle. We're doing the unit circle again. Oh. Okay. Third quadrant. Again, set it up, dividing by 2. Here's where things change. Are we on the top of the graph, above the x-axis right now? No, we're on the bottom. So we don't start with our 1 on the top left. Where should we start?
Right, bottom.
Bottom left. It's still on the left, because we always start on the x's. Bottom left. If I'm below the x-axis, I'm on the bottom of the graph. Start at the bottom left, and then work up in that column. 1, root 2, root 3. Circle around. 1, root 2, root 3. Yeah, which parts of this is negative? The x-axis or the y-axis? Both. Both.
Why?
Because the x-axis is negative. See how that's the negative half? The y-axis goes down. It's also the negative half. One more quadrant.
Do we start at the same place then?
So if we're below the x-axis, we're on the bottom of the graph, we would start on the bottom left. It's always on the left because you start with the x. Bottom left. So we get 1. What comes after 1? Not just 2. Root 2. Root 3, circle around. 1, root 2, root 3. Okay, this side of the room, I don't hear much coming from you. Does that make sense? Okay, there's a question. Can you be quiet, please? Oh, yes, thank you. So, Emma just pointed out, our negative this time is only the y. Okay, so that was the unit circle as far as we've learned it. Remember that the first coordinate represents one of the trig functions. Does the x-coordinate, Chibs? Yep. Is the first quadrant sine or cosine? Amy? Cosine, yes. They go in alphabetical order, so write that down. Cosine theta, sine theta. And now we'll finally go to tangent. But it's good practice to redo this because you're going to have to do it in a week. Or a week and a half for your test. Okay, so below, if you don't have room below, do it on the back.
So good. So good.
Like a quarter page. So if you don't have room, do it on the back.
Wait, what are we doing on the back?
I don't care. Find a corner. No, it's fine. Okay, SOHCAHTOA. Sine, SOHCAHTOA, so represents opposite over hypotenuse, right? Cosine, so ca, what's the ratio for cosine?
Adjacent and then
Hypotenuse. Like a glottal stop. Okay. Sine, so, opposite over hypotenuse. Cosine, ca. Tangent, which is one we're venturing into today, is TOA.
and it's opposite.
No. TOA.
Oh,
A, adjacent. That's the only one that doesn't have hypotenuse on the bottom. So, an interesting relationship happens when you make a ratio of sine to cosine. If we have sine to cosine ratio, which is a fraction, we just talked about this a few minutes ago. Forrest, how do we divide by a fraction? Copy, dot, flip. Yep, so we copy the first, dot, which means times, and flip the second. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Okay, Eric, do you see anything mathematically that's going to happen when we times those? What would happen? Yeah, hypotenuse cancels out, and we're left with opposite over adjacent, which is actually tangent. So, tangent is the ratio of sine divided by cosine. Tangent is the ratio sine divided by cosine. Tangent is the ratio sine divided by cosine. And remember, sine, like we've marked here, sine is the y. So sine is measuring the vertical movement or the rise. Cosine is the x, so it's measuring the horizontal movement or the run. Raise your hand if you rise over run sounds familiar, you know what it means. Thanks for not shining out and raising your hands. Emmanuel, what is rise over run? Right, but what are you measuring when you do rise over run? Starts with an S. Do you remember that? No? Okay, Nathan? Slope? Yeah, slope. So therefore, tangent is measuring, but the slope of what? Measuring the slope of the terminal side of the angle. The terminal side of the angle. Reminder what a terminal side is. We have an angle like this. In standard position, our initial side is always on the x-axis right there. And then if we rotate, the terminal side is where it ends. So this green one is the terminal side. So it would be measuring the slope of the ending ray of the angle. Okay? But it's sine divided by cosine. So we're going to work out the first quadrant to figure out the slopes of all these. Sine divided by cosine. So again, if you're running out of room, do it on the back. This is just scratch work, but I expect you to actually have this work out. Tangent of 0 degrees. Sine divided by cosine. Okay, put your fingers up in the air. What is the sine value of 0 degrees? Fingers in the air, please. Sine value of 0 degrees. Thank you. 0. Okay, show me the cosine of 0 degrees, please. Thank you. 1. So 0 divided by 1. What is 0 divided by 1? Silver, what's 0 divided by 1?
I don't know.
0.
So, not that one. Nope. You have 0 pizzas divided by 1 person. How much is that person going to eat? 0. 0. Okay, next, degree tangent. Tangent of 30 degrees. We need sine divided by cosine. This one's the most difficult one. Okay, all the rest come out nicely, but tangent 30 degrees, we have to do a little trick. Okay, sine divided by cosine. Oops. Okay, Benito, which one's sine for 30 degrees? Good, 1/2. So cosine then is root 3 over 2. All right, so let's write that out. 1/2 divided by root 3 over 2, which we've done this a couple times already today. Copy, dot, flip. Copy the first, dot, and flip the second. 2 over root 3. Okay, Joseph, what happens when we times these together? Yeah, they cancel each other out, right? So we get 1 over root 3. However, this is not the answer. Just like we never leave negative exponents in our answer, we never leave fractions or square roots in the denominator. So you have to do what's called rationalizing the denominator, which means we have to multiply by a fancy form of 1 to get the square root out of the denominator. So anyone remember how to rationalize the denominator or what that fancy form of 1 is? We're trying to get to the top, but we have to find what's that fancy form of 1 first. Silver? Yes, and we choose root 3 because that was the denominator. The fancy form of 1 is root 3 over 3. Root 3. Root 3 over root 3. This is 1 because anything divided by itself is 1. So we're not changing the problem. We're just manipulating it a little bit. So if we times those, in the numerator we get root 3. In the denominator I get root 9, which is a perfect square because 3 times 3 is 9. Noah, what's the square root of 9? 3. So now the root is on the top, and the denominator is good to go. So the tangent of 30 degrees, that was the hardest one. All the other ones are pretty nice. Because you can't leave a root in the denominator. So this is called rationalizing the denominator. And the way to get that out of the denominator and force it to the top is by timesing by root 3 over root 3. Okay? Now let's do tangent 45 degrees. We're just doing the first quadrant right now by hand. Tangent 45, Heather. Sine divided by cosine. What is the sine, Heather? Good, and what is the cosine? Ah, so what happens when you divide root 2 over 2 divided by root 2 over 2? Anything divided by itself is 1. That's nice. That's an easy one. 45s always come out nicely. Forrest, please don't do that. Okay, tangent of 60 degrees. So it's sine divided by cosine. Remember that. Anna, what for 60 degrees, what is the sine? Good, root 3 over 2. And then the cosine would be 1/2. So we do root 3 over 2 divided by 1/2.
Why is it?
Because sine is in the numerator, and sine is the second coordinate. Because sine is vertical distance. Sine's the second one. Remember how we wrote it right here? Sine second, Cosines first. Okay, now again we have that fraction in the denominator, so everyone say the phrase with me, please. Copy dot flip. Say it. Copy dot flip. Yeah, okay. We need to practice our choir skills. Okay, copy the first times and we flip. Danny, what's the flip?
The flip is 2 over 1.
Good. And when we flip, we're usually seeing a cancel, right? We've done this a few times. 2's cancel out, and we have root 3, but you don't really need to do over 1, right? How come this one's okay? This square root's okay. How come we don't have to fix this square root? Good, it's not in the denominator. Okay, the last one of this quadrant is 90 degrees. Sine over cosine. 90 degrees. Sine divided by cosine. You're doing it backwards. 1 divided by 0. Okay, please show me with your fingers in the air. What is the answer to the quotient of 1 divided by 0? It's error, right? We can't divide by 0. So, Silver, what's the word? Undefined. So the abbreviation is capital UND. Because this is really the slope. And the slope of this 90-degree terminal side is vertical. What's the slope of a vertical line?
No slope.
It's undefined. Slope of a horizontal line is 0. So let's go through our unit circle and write these down now. We have tangent of 0 degrees equals 0 because a flat line is a 0 slope. Then we did tangent of 30 degrees. That was the one we had to rationalize. Who has tangent 30 degrees? Square root 3 over 3. And then we did tangent 45 degrees. That was the nice one. Came out as 1. Tangent 60 degrees doesn't look that nice, but really it came out pretty nicely. Tangent 60 degrees, someone from this side of the room. Tangent 60 degrees, what is it? Square root 3. So even though it has a root, it came out nicely. And 90 degrees vertical line, undefined. So there's actually another angle here that is going to have a vertical slope. Which other angle has a vertical slope? 270. So tangent of 270 is also undefined. And there's another line here that has a flat slope.
Oh, that's 180.
180. So flat slopes are 0 degrees. Or not degrees, excuse me, 0. Tangent of 180 degrees is 0. So here's your homework. Shh. I'm still giving you time to... Arbor just got really excited about something. I'm still giving you time to finish page 404 and 417. Those are due on Tuesdays. And get your progress report signed. The only addition to what you've had for a couple of days is there are 9 more tangents you have to figure out. There are 3 more tangents we haven't done in the second quadrant, 3 in the third quadrant, and 3 in the fourth quadrant. So besides finishing your sine and cosine assignments, get your progress report signed. The only new addition that you haven't had in your pocket for 9 days by the time it's due is these last 9 tangents. Does it make sense how you do them? Sine divided by cosine.